from the power supplied by the current sources. Here current source as well as the voltage source are comes in series. Here the resistance value is 2.5 ohm. So the current through the voltage source is also 2.5 ohm, means 2 amps. So the voltage developed across the 2.5 ohms is the 5 volts. If we apply the KVL in the loop, then we will get the voltage across the current source as 5 volts. Again the polarity is given like this. Hence now the current is entering the positive terminal in the current source. That means the current source is absorbing the power. So power absorbed by the current source is nothing but voltage across the current source and the amount of current it is allowing through it. So 5 into 2, which is 10 watts and absorbed. Hence option D is correct. Pair of Zener diodes, each with a forward drop of 0.7 and the Zener diode voltage of 4.7 volts is connected as shown in the figure. The input voltage is a sinusoidal function, that is 10 sine of 2t. The peak to peak output voltage is, see, if we indicate two diodes D1 and D2, when Vs is the positive half cycle, then D2 is going to conduct whose forward drop is 0.7. Hence D1 is not going to be reverse breakdown. Hence the output voltage is towards the positive peak side, it is plus 0.7, and the negative half cycle of the Vs, the D1 is going to conduct whose forward drop is now 0.7. Hence D2 is not going to be in breakdown region. Hence negative peak side is, it is going to be minus 0.7. Hence peak to peak voltage is going to be 1.4 volts. Hence option C is correct. It's represented as 10101010 using 8 bits in sign magnitude representation. The decimal number represented as, we know that in sign magnitude representation, if it is an n bit number, the nth bit, that is MSB, is a sign bit, that is 1 for negative number, 0 for positive number. Remaining n minus 1 bits in the n bit representation represents the magnitude. So for a given number which is a 8 bit number, if we calculate the magnitude, that is MSB bit is 1, means the number which we are going to get is a negative number. If we calculate the magnitude, that is 10101010. So in magnitude calculation we should not use the MSB bit, but the remaining bits we can calculate for the magnitude. That is, this is the 0 position, 1 2 3 4 5 6 7. So negative 32 plus 8 plus 2, which is minus 42. Hence option A is correct. Is an NMOS transistor, the gate source input impedance is. So if we compare the input impedance of the three different type of transistor sources, BJT, JFET and the MOSFET. In case of BJT, the input junction, that is base emitter junction, is forward biased, whereas in case of JFET, PN junction is reverse biased. In case of MOSFET, the input junction is through the insulator. Hence the input impedance of these three transistors are in the following order. Hence if we goes to the statement 1, that is lower than the input impedance of BJT, so it is a false statement, and the second one is also false according to the comparison what we have here. And compared to the JFET, the input impedance of a MOS transistor is higher, as well as compared to the BJT as well. Hence third and fourth statements are true. Hence option C is correct. Is which of the following statement is correct? Here static 1 hazard may occur in 2-level AND OR gate network, and the statement B, static 0 hazard may occur in 2-level AND OR network. Statement C, that is dynamic hazard may occur in 2-level OR AND gate networks. Statement D, essential hazards may occur in combinational logic network. See, we know 4 different type of hazard, that is static 1 hazard, static 0 hazard, dynamic and essential hazards. Static 1 hazard occurs in AND OR networks, which can be implemented with product of some expressions, whereas static 0 hazard occurs in that is sum of product expression, that is OR AND network, whereas dynamic hazards occurs in all combinational circuits, not only in OR and AND. Whereas comes to essential hazards, these Hazards occur in sequential circuits, not in combinational circuits. Hence, option A is correct. Why does an FM radio station performance better than an AM radio station for radiating the same total power? We know that in case of an AM radiation, the information presents in the amplitude variations of a signal, whereas in case of FM radio station, the information mainly present in the frequency variations. Here, the noise mainly affects the amplitude variations. It doesn't affect the frequency variations. Hence, FM is more immune to noise compared to the AM. Hence, option A is correct. In FDM system used for telephone, which modulation scheme is adapted? Here, SSB-SE is used for the in FDM systems for the telephone, because in case of telephone, here the frequency range is nothing but the frequency range of the voice, whose frequency range is 300 Hz to 3300 Hz. Means there is a gap between the positive and negative frequencies, that is, this is the voice range 0.3 kHz to 3.3 kHz. So there is a gap from the origin, that is the lowest frequency, that is, so 300 Hz, which provides the transition band for the filter design. So there is no overlap in the lower sideband frequencies. Hence, most optimum choice is single sideband suppressed carrier. Hence, option C is correct. Diagram of a modem has 4 states as shown in the figure below. What is the bit rate for this modem? See, from the given constellation diagram, we came to know that it is having 4 symbols. Means for each symbol it requires 2 bits. Hence, the baud rate is nothing but bit rate divided by the number of bits per symbol. Here, bit rate is equals to number of bits per symbol is, here 4 symbols means 2 bits per symbol, that is twice the baud rate. Hence, option A is correct. Taking an antenna far-field pattern, what must be the distance between the transmitting and receiving antenna? See, in order to consider the far-field pattern, the distance must be between the transmitting and the receiving antenna depends upon the diameter of the antenna as well as the wavelength of the antenna. So, here the distance must be greater than 2d square by lambda, which is option A is correct. A lossless line having a characteristic impedance Z0 is terminated in a pure reactance of minus J20. The VSWR of the line will be. Here, for a lossless line, the characteristic impedance is nothing but a resistive. So, if we terminate it with an imaginary impedance, that is, we know that the reflection coefficient is ZL minus Z0 by ZL plus Z0. That is, minus J20 minus Z0 minus J20 plus Z0. The magnitude of the gamma is equals to 1. That means VSWR, that is equals to 1 plus gamma divided by 1 minus gamma. So the magnitude of the reflection coefficient is 1, means the VSWR is going to be infinite. Hence option D is correct. Z and G of Z are the one-sided Z transforms of discrete time functions f of nt and g of nt. The Z transform of summation of f of kt g of nt minus kt is given by. See, from the above given expression, that is sum of f of kt g of nt minus kt is nothing but the convolution of two functions f of nt g of nt. If it is in time domain, if it is convoluted, then it is in frequency domain or in z domain, it is going to be, if we apply the Z transform, it is going to be f of z and g of z. According to this one, hence option, according to this one, if we take the Z transforms of individual functions f of nt and g of nt, if we multiply those things, we will get option B as the correct option.